All right, everybody. So this is going to be the lecture 2 from week 5. Okay. So what we're going to be doing is we're going to be going over what we did not do in the previous lecture, which is mostly characters, I think. And after we do that, then we will take a look at the Zybooks exercises. So I'm going to download this set of lecture slides, which I probably downloaded before, but again, here they are. And we'll just jump into this. So last time we talked about typecasting and we talked about binary numbers. We did not talk about characters. So let's just skip to there. All right. So characters in Java are represented by the char type. So you'll hear people say different things. Some people will say character. Um, Nobody really says char. For some reason, they say char. Um, it's just a weird thing that people do. I'll just generally call them characters, but sometimes if I'm reading this, I would say like char letter equals a, something like that. Now, they are a type, just like integer is a type, or int is a type, double is a type, and they are one of our primitive types. And we know that they are a primitive type because the first letter of the type is lowercase, right? So you might remember that for primitive types, they were all lowercase. Int, double, those are the ones we use the most. But also there was long and there was short and there was float and there was Boolean, those things, right? And so they all have lowercase first letters. And so char is no different. Okay. And what they do is they can store a single Unicode character. Now, Unicode is a standard for basically text encoding, right? So under the hood, we have to represent letters just like we have to represent anything in the computer with binary data, right? Zeros and ones. And for a long time, what people used was ASCII. And so there's a link here to ASCII table, which is just one of the places where you'd be able to look at this. This is also in Zybooks. And this ugly looking table here is a table of basically what number goes with which keyboard symbol. So it's a little bit hard to look at here. It's easier in Zybooks, to be honest. But like if we move over to this side and we look here and you see the red column is what the keyboard symbol is. So this is like the keyboard at symbol, the keyboard capital A, B, C, D, E, right? So these are symbols on the keyboard. And you can look over on the left side where it says DEC, and that's basically the decimal number associated with it. So, like for example, this line right here tells you that letter A is number 65. Uh, and you could even uh, verify that yourself, which I don't think we really need to right now, but I will momentarily. And there's just 127 of these on this table, or I guess 128, because we start at zero, but zero is null. And so basically, back in the early days of computers, where we were getting personal computers, and they said, okay, we're going to need we're going to type stuff in. We need to represent text. They figured out how many symbols you might need in order to represent text. And you could see, well, there's like 26 lowercase letters and there's 26 uppercase letters, but then there's a bunch of other keyboard symbols you need, right? Like, square bracket, slashes, you need underscores, you need curly braces, you need the delete key, tildes in there, that's a like a tick mark, regular apostrophes over here. Like all of these things need to be represented. And so they figured out how many of them they needed to represent. And they came up with a format that takes actually 7 bits, and 7 bits can store 128 things, and 128 things was plenty back in the day. This is before, you know, people in the United States realized that there were people in other countries that needed, other symbols for their languages, right? So this is just basically like the English language alphabet plus a few other things. Whereas nowadays we need a lot more, right? Because first of all, European languages needs accent symbols. Sometimes they need extra letters. Then you have, things like Russian that have a different alphabet altogether. Then you have things like, like East Asian languages, you have Arabic, you have things like that. Obviously, you can't fit the symbols for these languages here in this 128 things, right? And so at some point they had to switch away from this, which this is called ASCII. You can see American Standard Code for Information Interchange. Um, so ASCII became not enough. And so because ASCII wasn't enough, they had to switch to something else. And the something else was Unicode. And so Unicode can store like many, 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 many symbols. So Unicode can easily handle all of the languages of the world in Unicode encoding. Uh, Even though we say that, we can sort of pretend that we're still using ASCII if we only need English language characters. So we can just use those numbers like, or not, we're not really using the numbers, but we can use the original like 128 ASCII symbols without any trouble, even though technically we've moved from ASCII to this newer system called Unicode. Okay. Now, just to show you now what I was talking about the numbers versus the letters, if I go to Eclipse, let's open it up. This is the what's left over from the lab when I just did the lab. If I do int, I'm just going to say C, I'll call it X, and we pick a number. So let's say 73, right? Now, of course, if I do system.out.println and I print X, I think that you understand that we're just going to get 73 printed, right? And there it is. But remember that we know how to typecast now. So what if I pretend that that's a character? Then what happens? I get I, capital I. Now, why do I get capital I? Well, I chose number 73 here, right? So if we go back to our web browser and we look for number 73 on the list, we'll see that number 73 is way over here, capital I. And so we still have the same association from like these 128 symbols, from the decimal number representation to what actual character they are. Now, do you need to know what character is what? Not necessarily. If we go over to the Zybooks for this, and we go into the week 5 homework and we look at characters, the last section, they're going to explain some of this stuff somewhere. I'm looking for the chart. You'll see that they have a nicer looking chart here for the ASCII numbers or ASCII letters. And they want you to refer to this. And so if they say like capital A is stored as what? Well, you're supposed to understand that there's a number associated with it, right? So you just go up on the list and you look to see what capital A is. And when you do, you'll find capital A here is actually number 65. And so you'll select 65. So you don't need to memorize it or anything, but just be aware that there is this table called, the character encoding as numbers in the ASCII standard. Also, they link to the same site that I did. And, this thing exists, right? The ASCII table exists. So, like, I could change this to 65. The number that we just found was capital A, and you'll see it is capital A when I print it out as a character. All right. So not too much here. One interesting thing is here it says 7 is stored as, and you'd be like 7, right? No. 7 is, and you have to look at the table. And if you look at the table, you'll find the numbers right here. and you'll see that 7 is actually 55. So things might not be what you expect them to be. Oh, oh no. They sneaky got me. So I just screwed up because look what they're doing here. When they're talking about characters, they put them in little quotes, single quotes. They did not put the 7 in single quotes. So this is the number 7. So the number 7 is the number 7. They're not asking us this, but if they had put single quotes around this, then that would have been 55, right? So let's see if I can do this. I was trying to think of how to do this. I think it'll work like this. So if I put 7, it's going to print 7, right? If I put char 7, we're going to get, well, actually, it was not visible because if you look at the ASCII table, number 7 is actually plays a bell song sound is what it does. So you don't see it. On the other hand, if you print 55, it prints 55. But if you print char 55, it prints a 7. So, um, yes, uh, number 55 in the ASCII table is number 7. But if you just put a 7 by itself, then that's not character 7. It's literally the number 7. So you get number 7, whatever. Um, so you have those. We have escape sequences. We've actually seen these, right? We've seen these because you've seen this one, right? You've seen the \n for going to a new line. There's some others. If you need a tab, you do it \t. If you need a single quote, you do it with single quote. If you need a double quote, use \double quote. Now, this is actually pretty useful a lot because if you think about it like this, you could say, like if I put in quotes here, my name is Greg Big Dummy, Big Dummy Hogan. Like this, I want like let's say that's what I want to print. I want to print my name is Greg Big Dummy Hogan. This is going to be an error because I can't have quotes printed like this because when it sees a double quote, it assumes that the double quote here is actually lining up with the double quote here and it ends the string and then things don't run. But if I want to actually print a double quote, I have to do \double quote and here \double quote. Then I can print this and it can say my name is Greg Big Dummy Hogan, right? So in order to do that, in order to print the quote symbol, you actually have to do a \, and then a quote symbol. And so that's called an escape sequence. And the escape character is that \. Okay. So those are important. Uh, so if you want to output hello, you'd have to type it like this one, right? You can also use \t to put tabs between things. So okay, tab by. It'd be okay, \t by. It's a little hard to read that way, but that's how you would type it. Now, if you want to actually print a \, oh, oh, this is annoying. Given string a \quote b, the first character stored in memory as 97, because a lowercase a apparently is 97. And then they say what is stored for the second character. So what they would expect you to be doing here is understanding that this is backslash quote, that's what that is. And backslash quote is the quote symbol. So they want you to look in the ASCII table for a backslash, not for a backslash, but for the double quote symbol. So the double quote symbol is somewhere where maybe I am blind, but we'll find it eventually. Oh, it was right there. So the double quote symbol is here and it's number 34. So there. All right. So, okay, let's go back to our slides and see what's in there. There. So this is an example, and this is done in the lab this week as well. There's a typo here. Actually, this is the same typo that was in the lab. This is probably how the typo got in the lab. That this example here doesn't run because the scanner here was declared as scanner SCNR, but here the whole word scanner was typed instead of SCNR. So this is a typo here. But the point is that you're going to need to read words in at some point. And these two methods, next and next line, are how you read words. So if I go over to Eclipse to demonstrate, I can go string, let's say name. And then let's tell somebody to type in their name. Type in your first name for now, like that. And then to read in the name, you would say name equals SCNR dot next. Now, we're used to next int for integers, and we're used to next double for doubles. But when you just have a next by itself, next reads one word. One word. Now, the reason I'm saying that's important, one word, is because if we were going to print out the word that we just printed now with system.out.println, and I just print the name here, proceed. What's the problem? SCNR cannot be resolved. Oh, this is missing the scanner. Scanner SCNR equals new scanner system in. All right. So type in your first name, I say Greg, and it prints out Greg, of course. Now, if I type in a longer name, Greg Hogan, I still just get Greg. That's because next specifically reads in one word. If you want to read an entire line of text, so I want to read two words, for example, then it's not next. You would have to use next line. And next line reads one line of text. So now if I do this, I'm going to type in Greg Hogan again, but instead of just getting the single word Greg back, I should get Greg Hogan. Oops, not there. Here. Right? So we get the entire line of text. So next and next line are used just like next int and next double, but they read one line or one word depending on whether you're using next line or just next. So what? All right, so we know that. It says that's it. Actually, it says that it. That it? Question mark. Um, so looking here, what do we have in this section? So they say you can have people reading characters. Um, oh, okay. Yeah, this is kind of a weird thing. So they're teaching you a weird thing here, and I didn't put it in the lecture notes, but it is kind of important. So I'll show you this weird thing. Okay. So we're not going to read anything in. Just do this. Character, I'm going to say C1, C2, C3. I've got three characters. Okay. So let's say C1 is, let's just say capital A, right? And when you do type in characters, if you're typing them in, single quotes is the way to do it. So let's type in B and let's type in C. So I have three characters now. And if I do system.out.print or print line, and if I print one of them, like C1, this is fine. I get A. If I print C2, I get B. If I print C3, I get C. Perfect, right? Now, you're used to adding pluses up here to print multiple things in one print line. So you might think like I can print AB by doing C1 plus C2, right? That seems reasonable. You'll be like, it's going to print AB, right? No, it is not. It's going to print a number. Look at that, 131. So you just get a weird number. And what that number is 131, which if I look back at our table of values, if you were to add the 65, which is A, and the 66, which is B, you're going to get 131. And that's what got printed out. So what happened here was we get a number here. We get 131, which is 65 plus 66. And so that's from the ASCII values of A and B. That's what's happening. Now, the reason it does that is because um, it does this because the plus was previously being used by us as a shortcut to what they call string concatenation, and which concatenation just means putting one after the other. And Java knows that a plus means string concatenation, but these aren't strings, they're characters, so it doesn't work. Um, but the plus works for strings, not for characters. Okay. And so it's the same thing really with numbers, right? Like uh you couldn't print a 3 next to a 3 this way, right? Or you can't print 34 like this. Like this is not going to print 34. It's going to print 7, right? 7. Um so you can't just the plus only means put them next to each other when it's strings. That's what it comes down to. So if you want to print the AB, you can, but you have to basically turn these into strings somehow. And the easiest way to turn this into strings is just to put an empty string. So, right, you put strings between quotes. And so if you just put empty quotes, now that's magically a string. So this is a string plus a character, and a string plus a character is a string, and a string plus a character is a string. And so this will just magically make it work now. So if I run this, you'll see that the first one, we get the number because it adds the ASCII numbers of C1 and C2. But the second one does a weird thing where putting these quotes here magically makes everything inside here a string. And then we get the actual text characters. Okay. And so they teach you that in the Zybooks. I don't really know why they teach you that in the Zybooks at this point, actually, but they do. And so There's a little section on that somewhere. Where is it? I thought I saw it. Oh yeah, here, I guess. So this is kind of seeing if you understand that. So if you do system.out print let one, so letter one, I guess, let one is A. So if you print one letter by itself, it will print the letter. If you try to print two letters together, like A and B, it will not do it. Right? This is exactly the same thing we just tried. So if you put two characters next to each other with a plus, what actually happens is it'll treat them like numbers and it'll add them together to get another number. Weird, but that's what it does. And then if you want to avoid that, you can add these double quotes to the beginning. So you just type it twice, double quote, double quote. Uh, and then magically, this makes everything turn into a string, and then you get the letters again. And so if you did this, this magically turns everything into a string. This prints letter one, which is A. Uh, this is going to print an asterisk, and then this is going to print letter two, which is a B. And so the question is it going to have spaces in it or not? Well, I don't see any spaces up here, so it's going to print the first one. There's a space there. There's a space there. I literally said, I don't see any spaces there, so it's going to be the first one. But there is a space there, and there is a space there. So yeah, there's actually going to be spaces around the star. I just didn't see them. They looked, I don't know why. For some reason, the quotes looked close to the asterisk to me, but I guess not. Um, okay. And then the last thing here that they want to teach you is that, and we've seen it, but when you're typing in characters, characters go in, well, I made that too big, single quotes, right? Strings go in double quotes. So that's important to understand. So if you do like string, I'm just gonna say I need a variable. Let's call it string X equals A. Character Y equals A. So when you type a character, you have to type it in single quotes. So the code that I just typed here, it runs. I'll just show you. It ran. Um, if you screw up the quotes, if you say it's a character and then use double quotes, you will get an error. See, I'm getting an error already. Error. So if it's a character, you have to surround it with single quotes, and then everything's fine. If it's a string, it should be in double quotes. So if I change it to single quotes, this is an error. So you can't have single quotes for the string. Even if it's one letter, it's still a string. So you just have to know this. Strings are double quotes, characters are single quotes. Not every programming language works this way. If you were programming in Java, sorry, we are programming in Java. If you were programming in Python, you would be able to write your strings with single quotes or with double quotes or with, I think there's a weird triple quote thing it does where you type a quote symbol three times. Um, yeah, but you have to do it right in Java. That means double quotes for strings and single quotes for characters. So when we're looking here, let's see here. Organize the code statements to output all combinations of the letters let one, let two, let three in the order shown below. After the final combination, end with a new line. Oh, okay. So we want these letters. Okay. Weird. So if we look at this, let one, so letter one is going to be the first letter typed in, so that's X. Let two is going to be the second letter, which is Y. And let three is going to be the third letter, which is Z. So what we've got is, let one, let two, let three is X and Y and Z. And it wants us just to print them out. So the order is what we need to care about. And we just drag them. We just drag them from here to here. So if you want to print X, Y, Z, then you're going to be printing let one, let two, let three, right? Because again, it's let one, let two, let three is the order. So XYZ is one, two, three. So you look here for what's going to print one, two, three. So what's going to print one, two, three is not this one. This is 132, 213, 123. So it looks like this one, but keep going. 312, 231, 321. Okay, so it's this. So it is 123, this one. So we put that, it would have to be here. It should be moved. Okay, there, like that. That's how it should be. So that'll print X, Y, Z. Now the next one is X, Z, Y. Also, we need the space. So you'll notice that some of these have a space in that first double quote. Actually, they all do at this point. So we don't have to think too hard about it. But, there needs to be a space to print a space. This one is X, Z, Y. And remember that, X, Y, Z is 1, 2, 3. So this one is 1 first, right? X is 1, Z is 3. So 1, 3, 2. So we need to look for 1, 3, 2 here. So actually, that's this one, 1, 3, 2. Then the next one is YXZ. So Y is 2, X is 1. So 213, which I guess is here, 213. Then you have ZXY. So Z is 3, and then 1, 312, 312, which is this one. Uh, I feel like it's really weird that these are all in order. They keep being in order. And then the last one here is ZYX, which is 321, I guess. So that's this one. And then it says end with a new line. So to end with a new line, there are no new lines here, so that must be this one. So there's one that's not used, I guess. And hopefully we did this right, but we'll find out. What? Oh, I did it wrong. So one of these is wrong. So the one that's wrong, we got the first one, second one, third one, and the fourth one is wrong. So first, second, third, fourth. Fourth one is wrong. First, second, third, fourth. So the fourth one is supposed to be 231. Okay, that's this. So that there wasn't actually an extra one. I just skipped one. So this is supposed to be the fourth thing that gets printed. So it goes uh here. All right. So it looks like I jumped from the third to the fifth, I guess. We still wrong? What? Oh. All right, let's look at them in order. So, okay, the first three are still right. So here, first, second, third, fourth. The fourth one should be 2, 3, 1. Here, the fourth one is 3, 1, 2. Oh, okay. I think I just put those out of order. This should be easy, right? We were just reading, putting the right ones in order, but somehow I screwed it up once and now everything is hard. Okay, so there we go. We did that. Now, one thing that you'll notice here in the challenge activities that they've done here, and also they did it here, that I did not mention yet is how to read a character. So if you come over here to Eclipse, something weird you might notice is like, let's say I have a character here called C1, and let's just say I have an integer here called, I don't know, X, right? We know that you can read an integer with X equals SCNR dot next int, right? That reads an integer. I'm missing, I don't have a scanner. So let me just put that in real quick. All right, there we go. So this runs, it's waiting for me to type in a number. I didn't print anything, but I type in a number, hit enter, we're good. Um, and now that we're dealing with characters, of course, the natural thing to say is, how do you get a character? And you might think, well, there's next int, next double. I mean, obviously there should be scnr dot next character, right? Like that seems obvious, but you'll see it didn't highlight the color. And if I try to run this, it doesn't run. There is no such thing as next character. So when you want to read one character from the user, you can't, not with just SCNR. So what you actually have to do is it's a two-step process. So we know that when you do next, you get one word, right? Hopefully you remember that. Um, and you may also remember that in order to get one character from a word, we did this in the lab, that there's this method called character at, and you put a number in there. And so you combine these two things where next is going to read a word and character at 0 gets the first letter. So it's a complicated command, but this what it does is it gets one word from the user and then only keeps the first character. That's what that line does. It's a bit complicated, but if I print it out now, system.out.println, just to show you what it does, I'm going to print C1. If I type a whole word here, actually I have to type a number because of this, so I'll type a number. And then if I type an entire word, like my name, Greg, you'll see it gets the G, capital G. So next reads one word, character at 0 gets the first letter of that word. And that's what you have to do when you want a letter. Now, they don't have to type a whole word in, right? Like they can just type, instead of typing a whole word here, I could just type, capital T and I'll get capital T. So it looks like I typed in a letter and I got a letter, but that's not quite what happened. I typed in a word and then I kept the first letter of the word. That's what happened. Okay. So a bit tricky to think about at first because they just are doing it with no explanation. But that is what's going on here. Having said that, what does it say? Print a message telling the user to press the letter to quit key. Num presses time to quit. Okay, so it's supposed to look like this. This is what's supposed to happen. So I'm going to copy all of this, okay, and I'm supposed to print it. So I'll just do a system.out.println, print line, and I'm just going to copy paste my text in there. Now, if I do this, of course, this is not what we're supposed to be doing because the Q, that's the letter that they're supposed to press to quit. And the 2 is how many times they're supposed to press it. And those are in variables. So basically, the letter to quit is supposed to be Q, and the num presses is supposed to be 2. So I just copy pasted this entire sentence here. If I run this, it will be wrong for sure. You'll see the first one was right. because we had a Q and a 2 in there and it was a Q and a 2, but they're going to change them, right? The Q is not going to stay Q, it's going to be X. The 2 is not going to stay 2, it's going to be 4. So they're in these variables. So what you have to do then is we can just say press the, and instead of Q, we want letter to quit. So letter to quit, and then open up the quotes again. So basically, I just put plus letter to quit in place of the Q. And then I have to do the same thing with this 2. Instead of a 2, it's supposed to be num presses. So right before the 2, I'll put quotes, delete the 2, and then put plus num presses, and then plus, and then quotes again, times to quit. So now this will be whatever letter it is, and num presses will be however many times they're supposed to press it. And really, the line that we just wrote here doesn't really have anything to do with characters, right? This was just fill in the correct variable name for the letter and fill in the correct variable name for the number of presses. Um, doesn't really have anything to do with characters. All right, that is it. So we did the whole section here, and also the lab has a similar thing on it to this. So take a look at the lab and you should be good to go for this week. We're going to be doing more strings next week, so there'll be a lot more of this stuff coming. All right, that is it for now. I will talk to you guys later.